It is hi everyone. It is lecture 7 of current electricity and the topic is EMF, terminal potential difference and the internal resistance of the cell. So what is EMF? The full form of EMF is electromotive force. But as the name says, it is not a force. It is the maximum potential difference between the electrodes of a cell. And the terminal potential difference, we can call it simply the potential difference between any 2 points in the electric circuits. Both are the potential difference. What is EMF? Its full form is electromotive force, but it is not a force. What is it? It is a maximum. It is maximum potential difference between the electrodes of a cell when current is not drawn from the from the cell. The circuit doesn't draw the current from the cell. That means it is a maximum potential difference between the electrodes of a cell when the circuit is open, when the electric circuit is open. What does that mean? We have an electric circuit. Here we connect voltmeter. Here we connect ammeter. Connect a cell or a battery along with key. This is the resistance. When key is open, that means circuit is not complete, circuit is open, then there is maximum potential difference between the electrodes of a cell. What does this higher, this longer streak stands for? There are two terminals of a cell or a battery now. First one is, we can say positive or the longer one. What does that mean? That means this terminal is having the higher potential. Terminal potential difference is a potential difference between any 2 points of the cell. So this is the higher potential and that the shorter line shows the lower potential. And there is difference between the potential of these two terminals. That is known as EMF when the circuit is open, when the current doesn't flow in the circuit, when the circuit doesn't draw the current from the cell. जब सर्किट ओपन होता है, जब सर्किट में करंट नहीं फ्लो हो रहा होता है, सेल से नहीं ड्रॉन हो रहा होता है, दैट टाइम जो इन टर्मिनल्स के बीच में मैक्सिमम पोटेंशियल डिफरेंस होता है, दैट इज नोन एज EMF. एंड व्हेन वी कनेक्ट द की, व्हेन वी स्विच ऑन द की, जब पूरा सर्किट कंप्लीट हो जाता है, देन करंट स्टार्ट्स फ्लोइंग. एंड व्हेन द करंट स्टार्ट्स फ्लोइंग, एट दैट टाइम between any 2 points there is potential difference. क्योंकि हमने when we discussed that how current flows through the conductors, then there we discussed that due to that potential difference current starts flowing. So in the circuit between any 2 points there is that potential difference. So that potential difference is known as terminal potential difference. When the current flows in the circuit, when the circuit is closed, करंट इज ड्रॉन फ्रॉम द सेल. तो टर्मिनल पोटेंशियल डिफरेंस होता है जब करंट फ्लो हो रहा होता है, जब सर्किट पूरा क्लोज होता है. बट EMF जो है वो मैक्सिमम पोटेंशियल डिफरेंस है इलेक्ट्रोड्स की बिटवीन का, व्हेन करंट इज नॉट ड्रॉन इन द सर्किट, जब सर्किट ओपन होता है. इन दिस सर्किट इज ओपन एंड इन दिस सर्किट इज क्लोज्ड. बट दोनों पोटेंशियल डिफरेंस है, बोथ आर पोटेंशियल डिफरेंस. वन इज बिटवीन द इलेक्ट्रोड्स एंड वन एनीवेयर इन द सर्किट. It is in the open circuit, it is in the closed circuit. It depends on R, it doesn't depends on R. And it is represented by, so EMF now you understand, it is not a force. It is a maximum potential difference between the electrodes of a cell when the circuit is open. It is represented by the letter this, EMF, and its value is greater than that of terminal potential difference, because in case of terminal potential difference, current starts flowing. When there is current starts flowing, there is also internal resistance also acts, क्योंकि जब current flow हो रहा है, there is some opposition in the path of electric current which is known as resistance. There is external resistance as well as internal resistance acts through the conductor, right? So the value decreases. So it is represented by EMF. It is a scalar quantity. And its SI unit is volt. Both have the same SI unit, which is volt, and measured by voltmeter. When the circuit is open, circuit is not complete, current doesn't flow, its voltmeter shows the reading of EMF, but when current starts flowing, it shows the reading of terminal potential difference. We can say terminal potential difference simply the potential difference. It is represented by V. So in case of terminal potential difference, how can we define it? EMF is maximum because the value of EMF is greater than that of terminal potential difference. Why? As I told you, in case of terminal potential difference, current is drawn from the cell. Current starts flowing through the circuit. When there is current starts flowing, internal resistance also acts there, due to which the value of the potential difference decreases. So in case of EMF, that is maximum, and in case of terminal potential difference, it's not maximum. It is just a potential difference. So it is potential difference. I write potential difference with PD. So it is a potential difference between any 2 points in the electric circuit when current is drawn from the cell. That means circuit is closed. Key is closed, circuit is closed, current starts flowing, so its value decreases naturally. And if we talk about how or by which letter it is represented, it is represented by the letter V. Terminal potential difference is represented by the letter V, and its SI unit is same as that of EMF, that is volt. It is measured by the voltmeter, which is connected always in parallel across the electric circuit, right? So it is measured by voltmeter, and we can also use galvanometer as an ammeter and as a voltmeter. We will study all these things in the upcoming lectures. So measured by voltmeter, it is connected in parallel. In the electric circuit, and it has high resistance. Voltmeter has high resistance. If we talk about the resistance of an ideal voltmeter, it is infinite. In case of ideal voltmeter, its value is, or its resistance will be infinite. It offers infinite resistance in case of ideal voltmeter, and the resistance of an ideal ammeter is equals to 0. So this is terminal potential difference. If we simply write the difference, what is the difference? As I told you, EMF is the maximum potential difference between the electrodes of a cell when current is drawn from cell, right? And terminal potential difference is the potential difference when potential difference of where potential difference between any 2 points of the circuit, between any 2 points of the circuit. Here current is not drawn, circuit is open, current is not drawn. Here when current is drawn, right? Current is not drawn in this case and current is drawn in this case. Another difference, here circuit is open, that's why current is not drawn here. But in this case, circuit is closed, that's why current is drawn. Its value decreases naturally from the EMF. EMF has the greater value of potential difference in comparison to terminal potential difference. You understand now why? Because here the current starts flowing, the internal resistance also offered through the conductor. Third point, EMF, the value of EMF does not depends upon the external resistance, does not depends upon the external resistance R. There is external resistance now in the electric circuit. So the value of EMF doesn't depend on R, because in case of EMF, current doesn't start flowing, current start flow ही नहीं होता है, तो resistance offer नहीं होता है. But the value of terminal potential difference depends on the external resistance R, because current starts flowing. So resistance affects the value of EMF, right? So terminal potential difference depends upon the external resistance R, right? Because V is equals to IR, and the value of I in case of terminal potential difference, when there is EMF and internal resistance and external resistance, I is equals to E upon R plus R. So here this depends on R, but EMF doesn't depends on the external resistance, right? So this is a difference between EMF and terminal potential difference. And if we talk about, I'll use a term which is internal resistance. As the name suggests, that the internal means it is internally. One is external resistance, which is represented by capital R, that we offer in the path of electric current. But internal resistance is internally the resistance which is offered by the electrolyte of a cell in the path of electric current. सेल के बीच में इंटरनली जो करंट फ्लो को अपोज करता है, दैट प्रॉपर्टी इज नोन एज इंटरनल रेजिस्टेंस. तो ये इलेक्ट्रोड्स और इलेक्ट्रोलाइट के बीच में करंट फ्लो को अपोज करता है, राइट? So the resistance offered by the electrolyte of a cell to the flow of electric current between its electrodes is known as internal resistance. Electrodes के बीच में जो current flow हो रहा है उसको oppose करता है, that is known as internal resistance. It is represented by the small r. It is represented by the letter small r. And this small r, this internal resistance depends on how many factors? There are 5 factors. Number 1, nature of the electrolyte. Electrolyte is a liquid kind of, that is in which the terminals or the electrodes are immersed, due to which current starts conducting. So it depends on the nature of the electrolyte, and it is directly proportional to the concentration of the electrolyte, that how much the electrolyte is concentrated. Next, R is directly proportional to the distance between the two electrodes, that how much distance they are apart from each other, the immersion rods. So it depends on, not directly proportional to the distance. It varies inversely to the area of the electrodes immersed in the electrolyte, that how much area of the immersion rods is immersed into that electrolyte. And last one, how does the temperature affect it? The internal resistance of a cell increases when there is decrease in the temperature of the electrolyte. When the temperature of the electrolyte decreases, the internal resistance increases. So these are the factors on which the internal resistance depends. There is relation between our internal resistance, EMF, and terminal potential difference of a cell. What is the relation? V is equals to E minus IR. What is V here? V is the terminal potential difference, and E is the EMF minus IR. IR is the product of current and internal resistance. The relation, so this relation shows that the value of terminal potential difference is less than that of EMF. So V is equals to E minus IR. This is the relation when current is drawn from the cell. Current is drawn, that's why the value of terminal potential difference is less than that of the value of EMF. But when the cell is being charged, then the value of this is equals to V is equals to E plus IR, EMF plus the product of current and internal resistance. And the value of current is equals to V upon R, but we consider both internal and external resistance. That's why the value of current is equals to I is equals to EMF upon external resistance plus internal resistance. And if we plot the graph between EMF and R, as in the difference, I told you that EMF doesn't depend on the external resistance. That's why the graph is a straight line parallel to the x-axis. So it doesn't vary, EMF doesn't vary. But when we plot the graph between terminal potential difference and the external and internal resistance, when both are equal, then it varies. Firstly, it varies linearly, then it becomes saturated at a point. This is the relation between these two. By this equation, we can find the expression for internal resistance. How can we find? The expression for R, internal resistance. As we write the relation between terminal potential difference and EMF, V is equals to EMF minus IR from Ohm's law. V is equals to IR. Just rewrite the equation firstly. This is the equation first. Rewrite the equation. Rewrite the equation number 1. How can we write? IR, here it is of minus sign. When it goes to the other side, it will be positive. So V plus IR is equals to EMF. Here IR is equals to, it is positive, then it goes to the other side, it will be negative, EMF minus V. Now R is equals to EMF minus V. It is multiplied, when it goes to the other side, it will be divided like that. And from this Ohm's law, what is the value of I? I is equals to V upon R. So put the value of I from here, from second equation to the equation number 3rd. Put equation number 2nd in equation number 3rd. Put the value of I from equation 2nd to equation 3rd. then the value of internal resistance is equals to EMF minus V upon I, V upon R. That means V upon R. R goes to the numerator. Rearrange this equation again. We just separate them. R is equals to E over V minus V upon V into R. So this is the another one expression. It depends on the numerical and the given values that which equation you want to use in that. If the value of E and V are given, use this equation. In case of when we talk about the potentiometers, then we use this relation to find the internal resistance E by V. We put the value of L1 and L2 on the place of E upon V. But the final expression for it will be E is E upon V minus 1 into R. So this is the final expression for the internal resistance. Internal resistance is equals to E by V minus 1 into R. So here the internal resistance topic ends. Okay, thank you. Give me a minute.